Today, we're going to talk about Stuxnet, a destructive computer virus found in June 2010, lurking in the databanks of power plants, traffic control systems, and factories around the world, 20 times more complex than any previous virus code. Stuxnet exploited security gaps that system creators are unaware of. These holes are known as zero days. A zero-day attack is an attack that exploits a previous unknown vulnerability in the computer application. It is called zero-day because the programmer has 0 days to fix the flaw. In other words, a patch is not available. It is common for individuals or companies who discover zero-day attacks to sell them to government agencies for use in cyber warfare. The most successful viruses exploited zero-day, and the details of a zero-day can be sold in black market for $100,000. Stuxnet take advantage of 4 zero days, and they all complement each other beautifully. It's just brilliantly executed. So, how does Stuxnet work? Let's take a look at it. First, infection. It can infect any machines with a Windows system, brandishing a digital certificate that seems to show it comes from a reliable company, and being able to evade automated detection systems. Second, research. Stuxnet will check whether a given machine is part of the target industrial control system made by Siemens. Such system is run by a programmable logic controller that we'll talk about later, and they're deployed in Iran to run high-speed centrifuges that help to enrich nuclear fuel. Third, update. If the system isn't a target, Stuxnet does nothing, but if it is, the worm will update itself. Fourth, compromise. The worm will compromise the target system's logic controllers and exploiting zero days. Fifth, control. In the beginning, the worm spies on the operations. Later on, it controls the centrifuges, make them spin themselves to failure, or even worse, explode. Eventually, deceive and destroy. It provides false feedback to outside controllers, ensuring that they won't know what's wrong until it's too late, and that will drive the outside controllers crazy. Sophisticated and brilliant. And this is why experts believe that Stuxnet required the largest and costless development effort in malware history. Developing its many capabilities would have required a team of highly capable programmers, in-depth knowledge of industrial process, and an interest in attacking industrial infrastructure. Roel Schauenberg, an antivirus researcher in Kaspersky Lab, believes that a team of 10 people would have needed at least 2 or 3 years to create it.
Stuxnet is, and you said this publicly already, enjoys some sort of nation-state backing, and the resources. Talk a little bit about what your thoughts are regarding the actual resources that are built, that was used to build into this thing.
Oh yeah, so Stuxnet is very sophisticated, as I was already mentioning, and it does a whole lot of novel things inside the code. So you really need a team probably from 5 to 10 people who are really top-level experts in their field to find all these different vulnerabilities, know how to work with these industrial control systems and all that stuff. And there must have been months and months of development, as well as testing. Because this is such a complex thing, there has to be lots of testing.
The question is,
need to be sure
what is the target of this elaborate virus, and who would be responsible? Stuxnet was designed to attack industrial programmable logic controllers, or PLCs. PLCs allow the automation of electromechanical process, such as those used to control machinery on factory assembly lines, amusement rides, or, most infamously, centrifuges for separating nuclear material. Rolf Langer, the researcher who extracted and decompiled the attacked code and eventually identified its target, first speculated publicly in September 2010 that the malware was of Israeli origin and that it targeted Iranian nuclear facilities. In a TED Talk recorded in 2011, Langer gives detailed information about how they tracked down the target. Considering most of the infections had been reported in Iran, and there was not thousands of targets in that area. They narrowed down their research to the Bushehr nuclear power plants and to the Natanz fuel enrichment plants. They found out some features about the virus by taking a careful look at the data structure in nearly 15,000 lines of code they got that looked pretty much like old-style assembly language.
The number 164 really stands out in that code. You can't overlook it. I started to research scientific literature on how these centrifuges are actually built in the tanks and found, well, they are structured in what is called a cascade, and each cascade holds 164 centrifuges. So that made sense. That was a match. And it even got better. These centrifuges in Iran are subdivided in 15 what is called stages. And guess what we found in the attack code? An almost identical structure. So again, that was a real good match, and this gave us very high confidence.
Several weeks of really hard labor with other results that they had got. Rolf and his group were very confident that the target is Natanz, and is only Natanz. However, he changed his opinion a bit about who was actually behind
quite
this.
widely reported that people assume that Mossad is the main entity behind this. Is that your opinion?
Okay, you really want to hear that, yeah? Okay. My opinion is that the Mossad is involved, but that the leading force is not Israel. So the leading force behind that is the cyber superpower. There is only one, and that's the United States. Fortunately, because otherwise our problems would even be bigger.
In July 2013, Edward Snowden confirmed that Stuxnet was cooperatively developed by the United States and Israel, aiming at attacking industrial systems, using multiple zero-day attacks, using digital signature to avoid being tracked by antivirus software. Stuxnet is a masterpiece with the most sophisticated code ever, and it has been used for a simple specific purpose.
We don't want Iran to get the bomb. It doesn't have anything.
This was the first real threat made by codes, a real with political ramification that all the engineers had to come to terms with, and the potential damage could be really serious, that beyond anyone's imagination. This is the war.